So here today we will discuss about the Laplace transform, and this is the first video of Laplace transform. So here we will discuss about the definitions of Laplace transform and also that how can I find the Laplace transform of some elementary functions. So here first let us discuss about the definitions of Laplace transform. So suppose if we consider here the function f of t, which is a continuous function, and the Laplace transform of this function, that is Laplace transform of any function f of t, is defined by L of f of t, and here this f of t is continuous function. And now the Laplace transform of the function f of t, that is first we have to multiply f of t by e to the power minus pt, and then we integrate over 0 to infinity. That means the Laplace transform of any function is defined by like this: L of f of t is equal to 0 to infinity e to the power minus pt into f of t dt, where this L of f of t sometimes is also give a function of p. So we can write that the Laplace transform of f of t is defined by f of p 0 to infinity e to the power minus pt f of t dt. So this is the definition of Laplace transform. That is L of f of t is equal to e to the power minus pt f of t dt, and we have to integrate over 0 to infinity. So now here we will find that how to find the Laplace transform of some elementary functions. Like here if we consider that f of t is equal to constant, if we consider f of t as an exponential function e to the power kt, if we consider f of t is equal to t to the power n, or n is any positive integer, if we consider f of t is equal to sine kt, if we consider f of t is equal to cos kt. So now these are taken by the some elementary functions. There is a constant function, exponential functions, an algebraic function, and a trigonometric function. So here now also you can consider here that f of t is equal to cos of hyperbolic at and sine of hyperbolic at. So now let us discuss one by one that how can we find the Laplace transform of elementary functions. So here if we take the Laplace transform of the function where f of t is equal to a, that means this is the constant function. Here is the constant function. So how can we find the Laplace transform of any constant function? Like, so here we can write that we know that L of f of t is equal to 0 to infinity e to the power minus pt f of t dt. See here that f of t is equal to a, so we can write 0 to infinity e to the power minus pt into a dt. See that this one is the improper integral, so we can write by like this: the limit m tends to infinity 0 to m e to the power minus pt into a dt. So how we can write a into limit m tends to infinity 0 to m e to the power minus pt dt. So now if we integrate this one, so we get a into limit m tends to infinity minus e to the power minus pt by p 0 to m. So now say that now if we put the upper limit and lower limit, we can say as m tends to infinity e to the power minus pt tends to 0. So it will be now a into 0, so minus of 0, and now if we put the lower limit, that is 0 minus 1 by p, and now if we simplify we will get this is a by p. And so now we can say that the Laplace transform of the any constant, that is f of the any Laplace transform of any constant function a, then the Laplace transform of this function is defined by a by b. Okay, and the next we will discuss that if we consider the function f of t is equal to e to the power kt, to the power kt. That means here that Laplace transform of f of t according to definition 0 to infinity e to the power minus pt into f of t dt. Here f of t is equal to e to the power kt, so we can write it 0 to infinity, and now we can write it by like this one. Similarly, this is the improper integral, 0 to m, and now if we integrate this one, so we can get now see that e to the power minus p minus k, this is also tends to 0 as m tends to infinity. So now if you put the limit, so you will get, so you will get 1 by p minus k. And similarly you can check that if f of t is equal to e to the power minus kt, then the Laplace transform of L of f of t is 1 by p plus k. Okay, so now I'm going to the next. So here we will take f of t as sin at, and here also we'll solve f of t as cos t. So now if we take the Laplace transform of f of t for the case sin at 0 to infinity e to the power minus pt into sin at dt. So and we know that we can write sin at as 1 by 2i e to the power I t minus e to the power minus I t. So now from here we can write 0 to infinity e to the power I t minus e to the power I t dt. And so now we can write by like this, e to the power minus pt into e to the power I t dt minus, we can write it. And now from here, so now I think up to this step it is clear to you. So next, what can I write? That from here we can write that 1 by 2i e to the power minus p minus I t dt minus 0 to infinity e to the power minus p plus I t dt. Okay, so now I'm just going to the next slide. That is what we get, 1 by 2i 0 to infinity e to the power minus p minus I t minus e to the power dt plus I t dt. So now if we integrate, what we get? Minus 1 by p minus a minus 1 by 2i. And so if we integrate, this will be plus 1 by p plus I into e to the power minus p plus I t 0 to infinity. So now say that this one also, that is e to the power minus p, when this will be tends to 0 as t tends to infinity. So you will get 1 by 2i. And now if you put the upper limit and lower limit, this will be 1 by p minus a, and this will be minus, yeah, sorry, minus, okay, plus, and if we put the lower limit here, it will minus 1 by p plus I. And now if we simplify, we will get p square plus a square, and we get a by p square plus x square. So this is the Laplace transform of sin at, that is L of sin at is equal to p by a by p square plus s square. Similarly, now if we want to find the Laplace transform of cos at, this one is also very simple. According to the definition, 0 to infinity e to the power minus pt into cos at dt, and we know that we can write cos at is equal to half e to the power I t plus e to the power minus I t. So now if we put e to the power minus, so we can write it very simply here, plus, and now if we simplify, this is also improper integral and tends to infinity you can take, so we will get half into minus of 1 by p minus a. I can do it now very clearly, that is minus 1 by p minus a e to the power t 0 to infinity minus half of 0 to infinity, and take it that both tends to 0 as uh, t tends to infinity. So now from here we can write that, that okay, I just show you here the calculation here, that is if we put here the upper limit and lower limits, upper limits will be 0, so next it will be 1 by 2, and this will be 1 by p minus a I, and this will be plus 1 by p plus I, and if we simplify, we will get half of 2p by p square plus a square, and this will be p by p square plus a square. So L of cos at is equal to, you can say, p divided by p square plus x square. And now I will show you the last for this video, the elementary function, where we take f of t is equal to t to the power n. That is the algebraic function. And when we consider, that is L of f of t is equal to what? F of t is equal to t to the power n, where n is any positive integer, or n is any positive integer. So that is, now according to definition we can write minus pt into t to the power n dt. Now see here, this is quite similar to the gamma function. So what is the definition of gamma function? That is gamma n is equal to 0 to infinity e to the power minus x into x to the power n minus 1 dx. So see, and then now here if we put that this one, that pt is equal to u, that is p dt is equal to du. So dt is equal to 1 by p du. So here what we get? That is 0 to infinity e to the power minus u, and as pt is equal to u, so this implies u is equal to u by p. That is u to the power n by p to the power n, and the value of dt is 1 by p du. So now the question is that how can I put the limit 0 and infinity? See that pt is equal to u, so t and u. So if we consider the limit 0 and infinity for p, so it will be 0 and this will be infinity, so the limit will be remain same. So now 0 to infinity e to the power minus u into q to the power n divided by p to the power n plus 1 du. So now we can write 1 by p to the power n plus 1, 0 to infinity e to the power minus u into q to the power n du. So now this is quite similar to gamma function. If we can write 1 by p to the power n plus 1, 0 to infinity e to the power minus u into u to the power n plus 1 minus 1 du. So see here that if we compare it with this one and this one, so we can write this one is equal to 1 by p to the power n plus 1 into gamma n plus 1. That means we can say now that L of f of t, that L of f of t, or if f of t is equal to t to the power n, where n is any positive integer, then the Laplace transform of f of t is gamma n plus 1 by p to the power n plus 1. So that means it will say that, now if we say that n is any positive integer, that is given, if n is any positive integer, then we can write this is factorial n by p to the power n plus 1. That means we know that when n is any positive integer, gamma n plus 1 is equal to n factorial, and if n is greater than 0, then we will write that the Laplace transform of f of t, where f of t is equal to t to the power n, this will be written with gamma n plus 1 by p to the power n plus 1. So I hope you understand this one. So thank you for watching the video. And also can say that now if we totally discuss here, that we will get some formulas from here. That is, the Laplace transform of any constant is 1 by p. Laplace transform of e to the power kt, that is 1 by p minus k when k is greater than 0, and 1 by p plus k when k is less than 0. L of sine at is equal to a by p square plus a square. L of cos at is equal to p by p square plus a square, and L of t to the power n is equal to factorial n by p to the power n plus 1 when n is any positive integer, and when n is greater than 0, you can write gamma n plus 1 by p to the power n plus 1. So you can write down all this as per formula and you can solve any type of problem. Like I just give you here some example like L of sine 2t. So you know that L of sine a t means a by p square plus a square. So here a is 2, so it will be 2 by p square plus L of cos 3t. You know L of cos 3t, cos at is p by p square plus a square. Here the value of a is 3, so it will be p by p square plus 9. L of e to the power 3t. Here you know L of e to the power kt is 1 by p minus k when k is greater than 0 and 1 by p plus k when k is less than 0. So L of e to the power 3t, it will be 1 by p minus 3 and L of e to the minus 2t 1 by p plus 2. And now L of t cube means here we know that L of t to the power n is equal to factorial n by p to the power n plus 1 when n is any positive integer. So here the value of n is 3, so it will be factored 3 by p to the power 3 plus 1, that is 6 by p to the power 4. And if now we find L of t to the power 3 by 2, we know that when n is greater than 0, then it will be gamma n plus 1 by p to the power n plus 1. That is now gamma 5 by 2, that is by p to the power 5 by 2. And L of any constant, that is L of 2, suppose if we consider here L of 2, that is 2 by p. If L of 3, that is 3 by p, that is the Laplace transform of any constant L of a is defined by a by p. So thank you for watching the video.